Okay, so I think the title of my talk was something like Design and Use of Message Handlers. This is the message handler you just saw in the last talk, which is from Messenger Library. This is what I actually use for almost all my actual application code. So when I make an application, it's a bunch of these guys that talk to each other. So here's the agenda. But now, I'm going to talk about design of a message handler. And I'm actually eventually going to show actual code, which is, if you have Messenger Library installed, it's called the YouTube main example project. It's when I did a couple years ago some YouTube videos on how to develop a project. And this is the actual result. But to really talk about the message handler I use, we have to talk about messaging patterns. Because messaging patterns is how these things interact with each other, because your application isn't one of these, or it could be. You could make an application with just one of these, but a complicated application is going to have multiple. And so how do they interact? What kind of messaging patterns do they follow? And I'm going to particularly talk about one pattern, which seems simple, request-reply. Send a request, get a reply. But it's more complicated than that. I'm going to talk about something I'm going to call a continuation. And I think this is the key point in the talk. I want to get across what a continuation is. But before we do that, we have to talk a bit about Messenger Library because, well, this is all I'm talking about Messenger Library here. And is Messenger Library a framework? And well, what is a framework anyway? I mean, so
we just had that presentation.
I know. So I'm going to get a slightly different take on what a framework is. What is a framework? Well, it frames how you work. That's what a framework is. It frames how you work. It's a set of what to do and what not to do. And I want to make the point that it's a set of rules, and the point of the set of rules is not so much telling you what to do, it's trying to restricting you. It's a framework. It frames how you work. It excludes rather than just includes. And the reason to exclude things is that you can't be an expert in everything. If you use all sorts of different techniques and mix them together, you end up with the big ball of mud, a very complicated application. You really got to say, we're going to use this set of techniques that really work together that we thought about, and we're really going to get good at those techniques. So it's not just we're going to use a certain technique, we're going to be expert in that technique. And if that technique isn't working properly, we're going to figure out why. How are we going to improve it? How are we going to improve it? So if you look at these frameworks, well, what we think of is they're actually packages of code and tools and templates. And I even include the JKI state machine as because it really is kind of a framework. It's at least a guide. It's not so strict as others, but it's guiding you. These are packages that support a mental framework. So there's a set of rules that sit behind. Whoever has developed these, I've developed these using my understanding of what the rules are. Actor framework, slightly different set of rules. DQMH, slightly different set of rules. A lot of rules are the same, but they're also different. So on frameworks, you have to recognize again that you have a set of rules. You have a framework in your head of how you attack a problem, what techniques you use. And it may be as you want to try to recognize your rules explicitly. And that's very difficult. It's very difficult to know what your rules you're following because to you they're obvious, they're implicit. It's only actually when you see someone else's code and you go, what the fuck are they doing? That you realize that actually you have rules and they have different rules. And it's easy to look at some other code and say, like the actor framework. You might say the actor framework, what? But that's because it's following a set of rules that you're not quite getting. And if you got those rules, maybe you say that actually, no, this is really good. The problem is it's very difficult to do that. So to use a framework, you have try to understand the mental framework that it's supporting. Like actor framework is nicely references actor, the actor model. You have to understand that what is going on. Messenger Library also, I tend to work with the actor model as well. And don't be afraid to exclude things. It's not a game of I'm a great developer, I'm using every single possible technique in my application. It's okay to say I'm restricting myself to this set of techniques that I can really work with and get good at. Okay, so what are the rules of the Messenger Library framework? Again, it's really hard to do. It's really hard to say what your rules are because perhaps the most important rules you take as implicit. I don't have to tell you what the important rules are because they're obvious. So the rules are basically you build your application from message handlers. This gives you dividing your problem into parts. You're doing from messenger handlers. And you communicate between the message handlers only by messages. That means there's no shared DVRs, action engines, tags, channels, whatever. There's thousands of ways you can communicate between loops. You do not do that. You do it only by messages. And the messages are actually, the message transport is actually simple. There's no message priority. A lot of frameworks have message priority in it. There's no message priority. And that's a simplification. We do not do message priority. And perhaps more subtle is there's no peer-to-peer. All the relationships between the message handlers are client-server or caller-callee or some kind of tree-like thing. So let me just show you that. So this is peers. This is, I've made an application, there's 5 bits, maybe there's a logging, there's a data acquisition, UI, whatever. And they can all talk to each other because they're all peers. You know, it's the data acquisition sends to the logging, sends to UI talks to all of them. That's fine, that worked great. But it works great because I've drawn 5 things. And I, as a human, can understand 5 things and how they relate at once. I don't need to divide my mentally this problem apart. I can understand. I've got DAC, I've got logging, I've got a UI. But if you start to get your thing bigger, you have more and more loops with more and more relationships, you can lose the ability to understand your application all at once. You know, this is going to work. This scales badly mentally. So a tree relationship is more, it's a hierarchy. It's the top loop is in charge, usually called main, usually. And I'm sorry, I say she. She controls these other loops. And then they have their own things they're in charge of. And the control goes down the tree. And there's communication up the tree, but it's different. So there's an asymmetry between the communication. And the thing to realize about a tree is each branch can be thought of as being isolated. So that branch on the side, control comes into that branch only through the top guy of that branch. And mostly the communication goes out through the top guy. The whole structure underneath is isolated. And because it's isolated, it's also abstractable. When you're working at the top level with the main, you don't have to worry about the details of this tree, this branch. You're just talking to the top guy. It's replaceable. You could swap that entire branch out and put in a different branch. Right? It's only one point of connection. It's not spider webbed all over your application with different things. It's just one point of connection. And it's more reusable because you could take that branch out and put it in a different application. Right? And then each part of this is branches, sub-branches, and so on. So there's a lot of abstraction, reusability, replaceability. Okay, so now let's go on to the topic of a messaging pattern. I'm going to talk about request-reply. Remember, we have no peers. There's a caller, a callee, or a client and a server. There's many ways of thinking about it, but it's a hierarchy. It's different. It's asymmetric. So here's the example of a real-world example of an email. So the email is to James, to me, from Joe, whoever Joe is. What are the latest figures? I need to write the report. And then Joe replied, here they are. And there's presumably the figures. So is this a request or reply? Member of the audience, Richard, request or reply? Is this email a request or a reply? It's a reply, yeah, it says read. Okay. What was the original request? What was the original request? Yeah, and now that I've got this reply, what am I going to do? I'm going to write a report. How did you know I was going to write the report? Okay, did Joe tell me to write a report? Who's telling me to write a report? I am. No, I wrote that. Joe didn't write, I need a report. I wrote that. In fact, I wrote almost everything in this email except for the body and the attachment. I addressed it to myself because I put in the original request, it's got from James. That's where the to comes from. The from Joe, we don't need to know. And I wrote the entire subject except for the re part. So this bit at the end is what I call the continuation. You could also call it a callback if you want to, because a callback is actually a very similar concept. This is something written by the original requester that comes back in the reply and it tells them what to do. So what I did, I needed to write a report. Maybe my boss asked me to write a report. I couldn't do it because I needed the figures. I asked Joe for the figures and included in the message an instruction to me of what to do with the reply when it comes back. That's the continuation. I'm continuing my action. I have started an action, asynchronously sent off something, did other stuff, and then when it came back asynchronously, I continued my action. So using messenger library messaging, Again, messenger library is mostly about messaging. As a framework of actors, that's different. It's like another level. This is what you should not do for request reply. Here, Joe has received the message, what are the latest figures? And so it's sent to me, here they are. That's not really a request reply. That's like a stimulate. He was stimulated. Anyone could have sent the message, what are the latest figures, not just me. He's assuming it was me. And when it comes back, here they are. I've got to know what am I doing with this? Here is what? I don't know. It doesn't tell me anything. What you really should do is this. He should receive the message, and then he must have some kind of reply to the message. He's not replying to me. He's replying to the message. The message has to contain the information like where the reply has to go, and what information to attach to it, so that the person getting the reply knows what to do. That's the continuation.
So James, can you go back one slide and then pop back? Okay. So replying to James's address there, here they are, and then the way it should be is replying to the actual message, because that's what Joe's interfacing with, is the message.
The message, yeah.
Okay.
One thing I'll go over later, a slight thing is, this is actually more complicated than this, because in this, Joe needs to know my address. And he needs to know what message to tell me. Right, he's saying, here they are. He don't actually have to say, write your report now here, or something like that. This is simpler, because he doesn't need to know anything about where the address is going, or what to actually write on the address, on the message. He just has to attach the figures. So this is what my message handler would look like. So if someone has told me, write the report, please, I'm a message handler. I can't do it, I need the figures, so I send a request, what are the latest figures, and I attach an address of where the reply comes to, so the little thing that the send has an input for reply address. And in Messenger Library, the key technology is the address, and addresses that can be configured. They're not just where to send a message, they can also be how to modify a message, how to relabel a message. Here we are relabeling the message, continue write report. And that continue ... write report is just a mnemonic for me, so I understand this is a continuation. Right? So, and in continue write report, I get the information and I write my report. All right, so you see I'm actually writing I am writing a request, but I'm also instructing what the reply should be to me. It's actually quite clear. How's my time? How's my time? No, this is for my talk. How's my time? Okay. Can you, Darren, tell me when there's 5 minutes left? And can you say, James, there's 5 minutes left, hurry up. All right. That annoying, stupid clock, I don't want a clock. What 2 variations on request reply did I just do? There's 2 variations of what I just did. One is called synchronous request-reply. This is like blocking. I asked what the time was, and I ignored everything else until I got that reply. And so the time was 17 minutes or whatever. That doesn't need a continuation because I know exactly what that information is, right? That's kind of an implicit continuation. And the other one is register notify. That means I registered with Darren. Tell me in the future when this happens. And I gave him a continuation. I told him exactly what to tell me so I would know what to do. Now again, that's stupid for a human because a human has a brain and a brain has memory. And I can figure out if someone says 5 minutes what they mean. But a message handler is a much simpler thing, much simpler thing. And it works much better to give a more explicit continuation. So here's synchronous request reply. Again, I'm writing my report. What are the latest figures? I have this, which is called a query in Messenger Library, that internally makes a temporary address, attaches it to the message, and then waits for a message to come back on that temporary address, destroys the temporary address, because we don't need it anymore, and returns the message. So that is blocking, that will wait. Now, in a lot of frameworks, they advise against using this kind of blocking request reply. But the reason is they often have, or some of them have at least peers, which means that I could request something, and that person could request from someone else who could request from me, and we could get a block, because everyone's waiting for everyone else to finish. In the kind of no peer thing where there's a caller and a callee, the caller is the only one ever making requests, and the callee can't make requests back up. They can only reply. Remember, Joe doesn't have James's address. He can't actually make a request to James. He can only reply to messages, right? So in that case, you can do this, and it's more like, did I put that there?
Does your framework enforce the no peer
No, in my,
You have to remember that during the design.
in my framework, my philosophy is make the right way the easy way, the natural way that if you use it. It is natural to have it structured this way, rather than it's totally enforced. You can break all those rules, but it takes effort. So you don't break the rules unless you have a good reason. I don't mind breaking the rules, but you should always do it with a good reason, and you should have a little bit of like, wait, why am I breaking the rules? Rather than I can't break the rules. So it's natural for Joe not to have James's address. It's natural to do that. James could pass Joe his address, and then you can do whatever you want. I've sometimes done that with things like Modbus communication, which is very synchronous request-reply. Has everyone used Modbus? It's very request-reply, request-reply. It's built that way, and so you kind of have to interface with it in this method. So I said, this is an implicit continuation. You can read it, right? I mean, LabVIEW is great for reading block diagrams. This kind of synchronous request-reply is, if you had seen my talk of like a couple of years ago, what would a sub-VI do? This is how sub-VIs work. Sub-VIs are essentially synchronous request-reply. And this is very simple. You can be asking 5 things for information before you build a report. Just wait for it all, branch it all together and write your report. It's very, very clear to write this way. And I use synchronous request-reply a lot in the kind of initialization parts of a program, where you're kind of juggling a lot of balls, you're doing a lot of things at once. Trying to do that asynchronously is very difficult, but synchronously is very easy. And the one side is, if you can do synchronous for a unit test is very easy. You can have your loop, this is a messenger library where you have a loop, you launch it, which means you start it running, and then you can talk to it. And doing a lot of synchronous stuff is easy and is good for making unit tests, even though you would use this thing more asynchronously in the actual application. So the other thing I did was I registered for a time to know when I got 5 minutes left. And in Messenger Library, there are special registration messages where I can say, Joe, I want to register for time left. I should say Darren, I guess. Darren, I should want to register for time left. And I attach my address. And again, I modify my address with a continuation. So I tell him exactly what to do. Because times left is too generic. I don't know times left of what. I can give the exact thing and specify what I get. And this is what Joe or Darren would have in their case. They have to have something called a registration book. It's called Observer Registry, but it's just a book where you write in who wants what. And it records the address. Messages coming in, the registration messages are sniffed out and acted on, put in the book. And then when something else happens, some timing action, maybe this happens once a second or whatever, you can notify times left to whoever's interested. So it's just, this is Messenger Library is designed to make messaging patterns easy. So that's quite a sophisticated messaging pattern, which is made easy by providing this registration book and the messages. And one thing I want to note is that if you look at this, this is a very generic timing component. It's obviously timing something. It provides times left, but it's not referring to a talk. It's not application specific. It's generic. Over here in the continuation is more specific, right? I'm timing my talk, right? So this is actually, the continuation actually can allow you to make components that are more reusable because they're more generic. They're simpler, they're more focused. I don't need a talk timer. I just need a timer. And on the other side, my thing calling it doesn't have to work in generic things. It can work in specific things. I can give a very, very specific message. So again, back to the trees. So the trees, again, we're doing requests or registrations down. And notifications and replies are going up. One slight thing you'll notice, I do have a bit of the replies or notifications going sideways. That seems like it's peer-to-peer, but it's not. It's because the caller, the top guy, has registered one thing to send a message to the other with a continuation, which is a more specific command for the other one. So that's not peer-to-peer, yet they're communicating. I don't know how difficult that is to understand. That's kind of a key thing in Messenger Library, that the control goes down, even though communication can go across. I'll just say that in the active framework, actually, they tend to not like that, right? In the active framework, you focus on straight up and down the tree.
We prefer a tree as you do peer-to-peer, again, as you do, the similarities between groups.
complicated messenger library is designed to make that kind of cross thing very easy. So you can actually say, I'm going to start my DAC.
Well, we can absolutely do this.
Yeah, I'm going to start my DAC, I'm going to start my logger, I'm going to tell the DAC to send its data messages and relabel it as log this message and send it to the logger. And there we go, it's going. And I'm sitting there. Top guy is often, in my applications, the top guy is often not doing much because he's a manager. He sets stuff up. No, manager does stuff. Manager does lots of stuff, lots of code to the top level guy because he's initializing things, starting them up, saying what's going to happen. But then he sits back and drinks coffee while everything's going on. It's very much management. And then when something needs to change, he jumps in and says, okay, you stop, change, you go away, you appear. Those are changes, right? So it is very much like a management.
For instance, if you have error handling, all the nodes will go to the one error handling. Wouldn't you get like a merge problem as well?
You can do that. What you can do is you can say one of these guys, top guy might create error handler, pass it to everyone and say this is where you send your errors. But he's still in charge of the error handler. And I generally don't do that, but you can do that. You can but you have to think about, are you making your application complicated? Often error handling or logging is just like throw it down the black hole. Everyone just throw their error messages into this black hole. It's not complicated. Yeah, you could. Yeah. And so messenger library is a library, not a framework. It provides the easy ways of setting up complicated messaging patterns. Then on top of that is how I actually work, which is sort of expressed by this template. You can use messenger library just the messaging.
So, like I was talking about in the grid back in February, I've started to play with some ways of doing message registrations that are managed by a caller actor with a couple of nesteds where I'm doing some of these kinds of things. Or I want you to do something, and when you do it, I want you to send a message to him.
Yep.
And I think that's similar to some of the things that
Yeah.
you're talking about. So it's allowed, and I think it's useful in some terms.
If I can make a criticism of the actor framework.
So what?
A criticism of the actor framework.
I don't work for an eye anymore. Knock yourself out.
If you're in the rules and it can't get it, it's too difficult or it can't do something, you can always drop back to, well, I can make a DVR here that I can share with a keyer, and then I can cross-link anywhere I want using, I don't know, a shared variable or something, right? You have to make it so this is the normal way you do it, and if you want to get a little more complicated, here's the ways you can expand that doesn't go straight to anything goes, right? So you need kind of depth.
I really do discourage. I mean, if you're the only time in an active framework system, for example, where I advise people to use a DVR is, this guy over here on the left is generating a couple of megabytes of data that I can send to this guy way over the right, but I'm not connecting them with the DVR. I'm sending the DVR through a message and routing it around. The DVR is just holding the chunk of data.
Yeah, but you got to be careful that you've got a stage of I'm doing it strictly this way, and then I'm bending the rules a bit before.
It's not dependent. I'm passing along the handle, and the DVR is temporary. It's
Yeah.
not preserved.
Yeah.
It's simply for that one
Yeah.
connection.
Yeah.
And that's just to get around the fundamental limitation of LabVIEW,
Right.
which is big data sets.
Yeah. So anyway, I'm finally going to talk about this message handling loop. If you have messenger library, I'm actually going to eventually, you can create this from create actor from template, which I think Richard showed. So I've talked about messaging patterns. What do we need to implement my framework? So we're doing one guy, and this is where he is, right? So he's no peers. He's got a caller, and I put a question mark because the caller isn't necessarily a messaging handler. It could be some other kind of code. And she starts a couple of sub-processes, sub-message handlers that he is in charge of. So I got to support requests from the calling code. So one thing is, because I don't know what the calling code wants to do, I don't know what the continuation is, I reply to every message, even if it's just a command, even though I got nothing to say. I always reply to every message. If there's no reply address attached, then I do nothing. Reply is a no-op. But if there's a reply there, I will always reply to it. I will provide notifications that can be registered for. Right, again, I'm providing information. I'm not thinking about what the caller needs. I'm thinking what is reasonable for me to provide, because I am a service to my caller.
James,
sorry.
5 minutes, get over.
So I'm providing notifications. I'm commanding the sub-actors. I'm in charge of them. I create them. I start them. I tell them when to shut down. And I use synchronous request-reply, especially on startup, because I know I am in charge. I know if it's okay for me to do synchronous request-reply without blocking, because I'm in charge of this branch. I do async request-reply with a continuation if I want to. I do a lot of register notify with continuation, so I know when something happens. So I tell my guy, you know, whenever a new data thing comes in, send me new data, or send that guy new data. Note again, as I said before, you can redirect the replies notifications across between your actors. And again, this is because you are in charge of this branch. You can set up all the communication. And I should acknowledge the ancestry of this template I'm doing. It was developed from the JKI state machine. It's got a single loop. There's no producer-consumer. It's one loop. It's got an event structure. The messages come in by user events. And it uses a string-by-string list of actions. They're called states, but they're not states, they're actions. There's a problem with the LabVIEW community that we use states when really we're talking about things to do. States are like idle, running. Doing this is not a state, it's an action. So again, I haven't really gone into the details of the messenger library, but launching is basically where the guy above me has created me, started me going. You always need some way to start your loops going. And all the details are hidden. But if you look in this little startup VI, on the top there's this actor's messenger, that's my address. Anything going to this actor's messenger comes in through this user event, this message received user event. The reason I have the address is I'm going to attach it to requests or registrations to my sub-actors. That's why I have my address, otherwise I wouldn't need it. My caller already has my address, he created me. And then also there's the observer notification registry, which is this little registration book. I can't see it, but down here would be the VI for acting on the registration messages. And then, of course, often these frameworks, there's some way to start up, and there's a self-initialized message, which is by default always the first thing you receive. So initialization code can go into this first case. So again, this follows the JKI state machine of using a string. Lines in the string are actions. And it goes through, so example, the shutdown actions are, you even have like comments and stuff in it. So comment, shutdown actions, clean up, exit. And the way this works, Richard actually kind of showed a thing, is that an event happens. You can define what actions, you can handle it right in the event case, but you also have follow-on actions that you go through and it executes the actions one by one. And then at the end, there's error handling. And if you saw my talk a couple years ago, what would a sub-VI do? This is really designed to execute exactly as if you had sub-VIs. So you can add sort of more sub-VIs in the chain. They're error chained, error handling's at the end. In the JKI state machine, error handling is right then and there if an error happens. This is only at the end of an action, of an overall action, an overall event. And again, this is from before where the point of the action is it's a stack, not a queue. So if you have sub-VI, A and B, and the sub-VI calls sub-VIs A1, A2, A1, A1, A1A, A1A, and A1B, they execute in a defined order always, right? And in a separated order, so all of A happens before all of B, right? That's called it's a call stack, it's a stack. It's not a queue. And often in message handlers or structures, we use a queue and we throw things on the back of the queue. 1 minute. I don't know what 1 minute means. You're supposed to use my continuation. So unfortunately, we're not going to have much time to show the example, but so the message is slightly more complicated. And I realize that if you look at this template, this message handler, it looks too complicated. But that's because a lot of the parts are used for different things. So if you receive a message, again, you can act on the message, just like an event. You got to keep the message because you got to reply to it. So the last thing you do, even after error handling, is reply. You reply to every message that comes in. You can, with this other wire, specify what the reply is at any point. So here, I haven't specified anywhere where the reply is. The reply is just a generic acknowledgement. It's just a message, it's got no information. But again, the caller could have attached a continuation. So there could be a very important message attached to it. So we're replying to everything. Another thing is that the error chains all the way through, and the error actually will go in the reply. I haven't had time to go into it, but when you have lots of asynchronous things going on, a big problem is error handling. What happens who handles the error of your 12 message handling loops? And so this kind of follows the thing that, the error is a responsibility of whoever called me. You said do X. I couldn't do X because I don't know what the hell X is. So you send an error message. So if this guy, for example, receives an action it doesn't understand, that's an unhandled message. That's an error, and we'll go back as an unhandled message.
What happens if the person doing it, what happens if you ignore the request? If you ignore.
All right. Yeah, I'm afraid I'll have to stop then. The rest of my talk was a couple of techniques about how you handle messages, how you make responsive, glossy updates, periodic actions, how you actually do things. There's a lot of things I built into it.
But yeah, there's also a lot of time for discussion, so if you have any questions for James, you can. Yeah, great time now.
Okay.
Yeah, thank you.
There is a demo, and actually I do some YouTube videos. A couple years ago I did some YouTube videos, which goes through actually building a demonstration. That demo is now part of Messenger Library examples.